Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Today in my bench I have this Peavey. It's a mixer. It's a powered mixer with a digital effect. The model number is xr-1600d, and it have 16 input, as you can see, 16 channel input. This is of course made by or made in USA, the United States of America, and this thing have a mixer and also a equalizer with a digital effect series. From taking a look online and viewing the history of these devices are made in United States and made by Peavey in the, I believe it is 1993 or about this year. This device has been came to me by a friend that work in entertainment, and this device have also two very beefy speakers. They're about 18-inch wide. Now I'm going to photo the speakers. After a while, I'm going now just to make a preview over this unit before I open it up. As you can see, this XLR female jack, the plastic cover has been taken off of the from its place, and all the plastic nuts of the jacks, the 6.5 millimeter jacks, has been loosened up. Now, what happened to this unit, that the owner of it, who owned it, he doesn't use it very often, so he kept it hidden and he stored it. The other day, before a week from now, he opened it up and he removed all of the connections, and he tried to clean it with the use of a brush and a blower. And he, as he said and as he described it, he did a very good job. Now, after he reassembled it, the device stopped working. As he would say, there is a effect and the indicator are working, but there is nothing coming out. There is no sound is coming out. Now my guess is that he messed something up with the circuit. I'm going to power it up, and before I'm going to power it up, I'm going to disassemble it, because these kind of devices has a very high voltage in it, and it is dangerous to run it without knowing what kind of work has been done in the inside. So I'm going to remove the screws from the case and turn it apart and see what kind of, if there is some short in the inside, because we don't want anything to go wrong or to increase the malfunction. So I'm going to do this and I will be back. Now I already removed the screws, and there is on the sides, as you can see here, there is a 20 screws, short type. Let me just grab one and show you what. Always the American devices have a very interesting screw teeth. These self-tappers type, but not like the Japanese. There is the soft kind of teeth and there is the plastic type, but this is between, and this is really hard to find. And there is from the sides, the handles of it, there is a 6 screws in each side. So I remove all of these, and I'm going to remove the cup, the coffee cup that I put the screws in it, and I'm going to see the guts. I'm trying to open the hood and see the guts of this beast. Oh my god, this is really, oh my god, this is really heavy. Oh, it's all metal and aluminum, and wow, if you see how much this thing weighs, you will expect to have more parts in it. Disconnect this jack and this jack over here from the power supply, and try to remove this control unit and see what happens. And sorry about that. This is the amplifier, as I believe. Where is the cooler on this thing? There is no cooler, as you can see on this thing, unless if they use a separate cooler for each device. I don't know. For each transistor, I don't know. There is coolers for the driver, the pre-drivers, and this board I believe is for the output. This board for the output transistors. As you can see here, if I zoom in a little bit, there is significant sign of rust on the screw heads, and there is rust in these area as well in the case. As you can see, rust residue. A very big transformers, dual transformers. This is 12 amp, I believe, each one of them. So the total, if they combine the two together, I believe the total power will be about 24 amps, and that is a huge power. If we take a look around here, there is something is burned up in this area over here. So I have a point. I may have a point not powering it up before I take a look and examine the circuits. As we can see here, I don't believe you can see it, but there is a corrosion in the rectifier legs, and there is a corrosion in this area over here. If I zoom in, what this part is, oh, this is a rectifier. It's a 5-volt rectifier, fuses, and this is all what it is here present in the down unit. So this is the base unit. All this what you are seeing, it is mounted in the body or the downside of the mixer. Now I'm going to show you the inside of the downside of the control unit. This is the downside of the control unit. As you can see, this is the processor. It must to be the effect control board, and couple of AMPs, preamp, these devices over here, a dip, and this is the jacks for it. If I zoom in at the jacks, I believe I might find the problem. There is a loosen connector over here, or the loose wire from the jack from the header, as you can see. This is here, and the other one is right, the yellow one, as you can see. So he must yank them when he was cleaning up the unit. But there is no harm in inspecting all of the component before we power it up. First part of the inspecting, I'm going to inspect the power supply board. I'm going to test the fuses and see if there is something wrong with this circuit. And there is something interesting. There is something that corroded and something that ate the wire, this wire over here. I'm going just to zoom in a little bit in order to see. As you can see, something ate and scratched the isolation in this wire over here. Now, from the looks of it, there is no blown fuses. This is the ceramic fuses for 10 amp, and they are rated for 10 amp. This is what written beneath the fuses. And I'm going to test each fuse and each rail aside. I'm going to pause this video and perform this test, and then test the AMP and see if there is something is blown in the amplifier board. Now, after testing the fuses, these 10 pair are working fine. This, don't know what it is. It's 2 amp. It is working fine. These two, what the hell? They are 10 amp also. These two 10 amps are also working fine. But these 3 fuses, they are blown. This is a half a amp, a 1, and also 1 amp. This is 1 amp and this is 1 amp fuses. These two 1 amp fuses, they are blown, and this half amp, it is also blown. Now I'm going to get the schematic and see where are they leading to and what part of this circuit they are powering up, or they are supplying, or they are feeding through. This doesn't please me whatsoever, because I believe there is a short that led to this blown up fuses. So there must to be a short in somewhere in the control. There's something wrong in the control. But let's not jump to conclusions. Let's test each circuit, and we will cross this bridge when we reach it. But there is a short that indicates these fuses has been blown by it. Now I'm going to bring the schematic and see if there is a schematic for this device and study it thoroughly before I disassembled this board. I'm not going to mount the fuses and replace the fuses and hope for the circuit to work, because I seen it in many cases. I replaced the fuses and that increased the burn or increased the short or increased the damage. So I'm going to do that and I will be back. And before I look online, I decided to flip or turn the unit on its side and take a look at the down of the unit, and I found this 15 centimeter by 15 centimeter huge fan. And if we zoom in a little bit, we can barely see the transistors in it. So they are these type of metal transistors. So yeah, there is a coolers and there is a huge fan to cool them down. Wow. What handcrafted in the USA. Kudos to that. You can't see these anymore. These kind of devices, they are made in the United States. It's all China now. Wow. This device is heavy, and that is because there is two huge transformers in it. Now I'm going to take a look and see the schematic online and hope for the best. So after searching online, I found that this schematic, it is for model XR-800, the 1200 and 1600. The only difference between these models is the power of the amplifier section and the number of the input channels. So after reviewing the schematic, if we scroll down a little bit, we find that they are using the typical LM3915. It's an LED driver IC. It's a very common and a very reliable IC. It is made by National Semiconductors, and there is a 22 volt positive power, and it is also fed by 16 volt positive volts. Also, if we scroll down a little bit, we can also find another one of the same IC, and if we scroll on the side, if we can see they are using also another one, and also another of the same LM3915. So basically they are using 4 ICs for driving a string or a about 1 2 3 4 5 6 7 8 9 10 LEDs, bar, as a bar graph, as a bar LEDs. Each one of the IC, they control, they play a role of a view meter, an LED view meter. So this is for the left LED array, and this is the right for the LED array, and this is the monitor B LED array, and this is the monitor A LED array, and they are all supplied with the positive 22 volts and also a positive 16 volts. If we scroll down a little bit, this is the important part of the circuit. We can find they are using two ICs, the 7915 this is minus 15 volt, and the 7815, this is a positive 15 volts. These two ICs, they are designed for producing or regulating a stable 14.8 maximum voltage, VCC voltage, not 16 volts minus and plus like they are saying here. This is wrong. This type of IC, they can handle a 1 amp maximum, and they can produce a between a 14.5 and a 14.8 depending on the manufacturer of this IC. So the input of this these two IC is the negative 22, or the supply for these two regulator ICs is the negative 22 volts and the positive 22 volts. So I believe these two ICs are the main VCC section for the entire op amp, like this IC over here, the 4558, and these type of ICs, they are very common, and they are an op amp IC or a pre-amplifier ICs. And now, after we knew what kind of voltage we are dealing with, it is a lot more easy now to repair this mixer. This section over here, it is the graphic equalizer, and the neat thing about these type of mixers that they are using manual VR for adjusting an equalizer. This kind of neat feature, this kind of build produces a very satisfying control, and I like it more than the newer kind of mixer that it is digital. I don't like digital in regarding equalizer. If we can find here also, they are using this kind of weird IC number 3678. It's also an op amp, and also it is designed for controlling the sound. EFX A master, and this is a transistor. This type of transistors, they are fat, they are very sensitive for when you are dealing with they are static kind of transistors. So if he tempered these, we will have to see. All of these op amp, and they are using the 4560. It's also an op amp and an amplifier output. So all of the circuits, they are fed to these ICs that I previously shown, and they are shown in the schematic. If we take a look at this area over here, this is a schematic for the main power supply that I previously tested the fuses in it, and these two are the 1 amp fuses. They were blown, and these fuses feed this rectifier diode and produces the positive and the negative 22 volts. And this is also the half an amp fuse that it was also blown, and this also feeds this rectifier diode and produces the plus 48 volts. So yeah, and this is the wiring of the fuse board and the power supply board that I tested the fuse in it. And these are the two fuses that they were tested blown, these two 1 amp. So what I'm going to do, I'm going to disconnect these diodes and test each one of them aside, and test these capacitors, see if they are leaky or off value. And also the same procedure is going to be applied to this 48 volt rail over here. And after studying the circuit, I believe they are using one transformer for supplying each of the amplifier section. So the left amplifier, it is fed by one transformer, and the right, it is fed by another transformer. This is a very, very cool design, and I like the construction of it. It is very, very cool.